Hi, this is ET370, Lecture 8, Part C, and here we're going to continue our discussion on a practical implementation of a PMOS. It should look very similar to the previous lecture here. And so what do we have? We have a PMOS and a load, and we have 10 volts across it. And remember the PMOS or the NMOS, they're just acting like a switch. And so when this is closed, the voltage allows current to flow through the resistor here. And imagine we have an input voltage, and when this is low voltage, then the PMOS will be in triode and current will flow. Okay, low voltage. Now, if we can bring this input voltage all the way up to 10, which matches the source, then this gate source voltage will be nearly zero, or it will be zero actually. And what will happen? This will be fully cut off and nothing will flow. Now the problem is if you can only reach 5 volts, right, like in Arduino, and you can't reach 10 volts, you won't be able to fully shut off this PMOS. That's no good, right? And so the solution is going to be very similar to the previous example in the NMOS, where what if we add a little helper NPN and a pull-up resistor? So we have our PMOS, the pull-up resistor, NPN, and now we have an input voltage like in Arduino that only has to go between 0 and 5 volts. So let's walk through an example of how this works. So when the input is low, let's look at what happens. When the input is low, this NPN is off. When this is off, the gate is actually pulled all the way up to the 10 volt, which means this is also off. Okay, so this PMOS shuts off when this is off. When this VN is 5 volts, so it doesn't have to be 10, 5 volts, then this NPN turns on because we can get enough base current. And this gate essentially shorts to ground, and now this thing fully turns on, this PMOS fully turns on, is in triode mode. And notice the input logic is reversed relative to this case, right? And so now it's kind of like 0 volts turns it off, 5 volts turns it on. So again, the problem is, just like in the NMOS case, if this VS goes too high, this VGS is going to swing too much, right? Right now, VGS only swings between 0 and 10, and that's fine. But if we go back to our data sheet, let's see if I have it, the data sheet, yep, perfect. This is the 4905, which is a PMOS. It can only swing between plus or minus 20 volts, right? And so just like in the previous case, we can use a Zener diode here. So just put a Zener diode right there. And this will allow our voltage source to go all the way up to 100 volts or whatever we want. We can set the back voltage here, the breakdown voltage, to 80 volts. And so that way, this VGS will at most be 20. And so let's walk through again how this works. So this back voltage, this kind of pressure relief valve, is 80 volts now. Let's say VN is 5. If this VN is 5, this is essentially shorted, right? So this is grounding the other end of the Zener diode. And so because the back voltage of this guy is 80, then the gate voltage is going to be 80. So 80 from here to here, the node voltage. By KVL, you can see if this is 80 and this is 100, the difference here is only going to be 20, right? And now we've satisfied our condition where we don't want this to be greater than 20 volts, right? And in fact, it'll be minus 20 based on the polarities, okay? And in this case, when this is 20 volts, this is going to be in triode, fully turning on, yay. Right? Now, if I set the voltage here at the input low, this is going to open up this NPN, and this is just going to be pulled all the way up to the 100, fully shutting this off in cutoff, right? Okay, so this is just a simple implementation or practical implementation of a PMOS, and we'll actually be using this version here in the three-phase inverter, but let's go to the simulation and see this in action, okay? So here I have the 3 versions. I have just the simple case where my gate can actually swing between 0 and 10 volts. And so let me just run this so you can see. So right now, the gate voltage is at 10, fully turning off the PMOS. And when I bring it down to 0, then it turns on. Okay. Now, again, the gate voltage, requiring the gate voltage to go between 0 and 10 is a hard ask for an Arduino because it can only go to 3.3 or 5. But now we have a little NPN helper transistor, and we can have some non-inverted logic, right? We have basically now when this is going to be low, the PMOS is off, right? So if I bring the gate voltage to 5 volts only, not 10, notice this now turns on, okay? And I have my pull-up resistor. Okay, so again, the problem with this is, well, what happens if the source voltage goes from 10 to 100, right? Before in this one, VGS only goes from 0 to 10, no problem. But here with the helper Zener diode with the back voltage of 80 volts here, we are good. And so let's try it. So run this gate. So now when this goes high, notice the voltage here is 80 volts, which means the difference though by KVL is only 20. So you're not breaking the diode. You're still getting the on and off behavior of the PMOS transistor, low voltage off, high voltage on. These two are inverted logic relative to the first one. Okay, I hope this lecture helped, and I look forward to seeing you in the next 3-phase inverter lecture. All right, have a good one.